Okay, in this next video, we're going to begin our nomenclature unit. Alright, so in dealing specifically with alkanes, we have to know our prefixes. Our prefixes run from low to high, and we'll run through them. It's meth, eth, prop, bute, right? And we'll continue down here. Pent, hex, hept, oct, should say octa, nona, and then deca. Right? Now, keep in mind, these are just your basic prefixes. Now, if we're naming alkanes, this would just be methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Right? So, keep that in mind. What similarity do we see? Well, for our alkanes, we have this ane ending through all of the names. Right? Now, alkenes are our next group. Right? But first we'll get into certain attachments and styles of attachments. Now keep in mind that for meth, this is 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These can be added on in different ways. So for example, instead of methane, we can have methyl, which instead of a carbon with 4 hydrogens, we have a carbon with 3 hydrogens, except it's attached to something, right? That would be our methyl group. So let's run through all the ones that you need to know. This one is methyl, which we just drew, right? The next one that you'll need to know are your ethyl groups, right? And ethyl, as we mentioned before, has 2 carbons. So here's your attachment point, and then you'll have CH2, CH3. Now, although it might seem easy for me to write on the board, it's important to understand that carbon can only have 4 bonds, right? So if we look at this carbon right here, and I'll underline it with green, if we look at this carbon, we are symbolizing with this symbol here that we are attaching it somewhere. That's going to be one of the 4 bonds. We have 2 hydrogens, so now 3 of the bonds are taken up, and then 1 bond going to the next carbon. So that's 4 bonds taken up. Carbon can only have 4 bonds, so make sure that when you draw your structures that is correct. All right, the next group that we'll get into are propyl and butyl groups. Now remember, propyl has 3 carbons, and our butyl groups have 4, right? So our propyl groups can have 2 ways of being attached. Our first way is just in the straight chain format, CH2, CH2, CH3. This is called propyl. Now, keep in mind that if we were to attach it here or here, it's in the same spot, right? We're just flipping the molecule around. So, technically, there's only one way of doing that. The other way we can connect this propyl group is if we were to have a CH3 bound to a CH, bound to a CH3 with the attachment in the middle. This is what we call isopropyl. The propyl groups are fairly basic to name as attachments because there are only 2. The tricky ones come in when we begin naming the butyl groups. Right? Now remember, before I make a new page, that butyl has 4 carbons. So butyl contains 4 big groups. First, you have your straight chain butyl. CH2, 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 CH3. All right. Our next group is the sec-butyl group. Now, our sec-butyl group is the same as our butyl group in that it's attached as part of a straight chain. Now, remember from before, if we attach the butyl group at carbon 1 or carbon 4, it's the same thing. So for sec-butyl, we can only have one more spot of attachment. It's here or here. Not going to make a difference. So for sec-butyl, we have CH3, CH2, CH, CH3. And then the attachment falls onto this carbon. One way that students choose to remember this is that this carbon is a secondary carbon because the carbon has two carbon groups attached to it. Secondary, sec, right? We have two more butyl groups to get through. We have our isobutyl and our tert butyl, or tertiary butyl. For our isobutyl, we still have this 4-carbon structure, except now instead of a straight chain, it's rearranged. So here we have our CH3, CH, CH3, CH2, and then our attachment. This is our isobutyl. Now for some of these, there's no shortcut with regards to memorization. You just have to memorize the structure and work alongside that. Some students choose to think of these carbons as isolated. In other words, you have this central carbon, and then these carbons are all isolated. So it would be an isobutyl group. If that works, go right ahead. Our last group is what's called the tertiary butyl group, or for short, tert butyl. In the same format, you have a T-shaped. So that's what you want to think. T-shaped. So you have your CH3, right, bound to carbon, CH3, to CH3. And your attachment point is right there on the tertiary carbon. Right, so you can think of it as T-shaped or tertiary carbon, as you have a carbon with 3 groups attached. Right? Now we have some other groups, right? We have our chloro, our bromo, and etc. So our chloro groups means that there's a chlorine attached. Bromo means that there's a bromine attached. And then you have your iodo. And then your nitro and your amino. Your nitro group looks like this, and your amino group looks like this. Now, some of these upcoming prefixes are not the same as the ones we wrote before, meth, eth, prop, but. These prefixes signify how many of those functional groups exist in solution. So the prefixes used before told us how many carbons are involved. These upcoming prefixes tell us how many of these groups. So for example, if a molecule had 3 chlorines on it, when we begin our naming, we'll say trichloro. So the ones you have to memorize are di, tri, tetra, and penta. Di, tri, tetra, penta. So this is 2, 3, 4, and 5. And these will help us with our naming. Right. And in the next video, we'll get into our alkenes, alkynes, cycloalkenes, aromatics, and our cis and trans.